Hi, my name is Vivan Singh. I'm a third year undergrad currently pursuing BTech in Computer Science from Bennett University, which is in Greater Noida. Today, I'm going to enlighten on the topic DNS, that is Domain Name System, and now we'll see the topics that I will be covering in this presentation. So, this is basically the outline for my PPT. The topics which I'll be covering is first, what is DNS? How does DNS works? The DNS servers, how many DNS servers are there and how do they work? What is DNS lookup? An example of how generally DNS works. DNS resolver, what are the types of DNS queries, DNA caching, and also the DNS features. So starting with DNS, it is one of the most important things in the computer networks. The domain name system is the hierarchical and the decentralized naming system used to identify computers, services, and the other resources reachable through the internet or through IP protocol networks. It basically acts like a phone book of the internet. We access information on the internet through domain names. For example, when we write a domain name in the web browser, which interacts through the IP protocol, which the DNS then translates into the IP address so that the internet resource can be reloaded. So DNS is nothing but DNS is like a collection of databases that contain certain information about domain names and their corresponding IP addresses. It is like a phone book of the internet, like I said before. So, humans access information online through domain names, like www.google.com or amazon.com. So, these web browsers interact through IP protocol addresses. Then again, the DNS translates these names to IP addresses and which the browser loads from the internet resources that web page. Now, how does the DNS works? So, the process of DNS resolution involves converting a host name, such as www.example.com. Now, it is converted into a computer-friendly IP addresses. Let's suppose the domain name we entered was example.com. It is converted into an IP such as 192.168.1.1. So an IP address is given to each device on the internet, and that address is necessary to find the appropriate internet devices. Like a street address is used to find a particular home. When a user wants to load a web page, a transition must occur between what a user types into their web browsers and the machine-friendly address is necessary to locate the web page. So, a large number of DNS servers may be involved to get the right IP address. After receiving the correct IP address, the communication between the two computers starts. Now, talking about the DNS server. So basically, there are four main DNS servers: the DNS recurser, the root name server, the TLD name server, and the authoritative name server. So talking about the DNS recurser. So DNS recurser is a server which is designed to receive queries from client machines through applications such as like web browser. So it can be thought of as a librarian who is asked to go and find a particular book somewhere in the library. Talking about the root server. So the root server is the first step in translating the human readable host names into their IP addresses. Typically, it serves as a reference to other more specific locations. Now the TLD, the top level domain server, can be thought of as a specific rack of books in a library. This name server is the next step in the search for the IP addresses, and it hosts the last portion of a host name. For example, in example.com, the TLD server is com. Now, the authoritative name server. So the authoritative name server is the last stop in the name server query. If the if this name server has access to the requested record, it will return the IP address for the requested hostname back to the DNS recursion. That is the librarian that made the initial request. So now let me explain you with an example how DNS works. Right. So when we type the most basic websites that we use on a daily basis is google.com. So like when we typed google.com in a web browser, it basically asks the local DNS server at the ISP's end for its IP address. When the local DNS server does not find the IP address of the given name, it forwards request to root DNS server and again inquire about the IP address of it. Then the root DNS server replies, I do not know the IP address of www.google.com, but knows the IP address of the COM DNS server. Then the local DNS server then asks the COM DNS server for its IP address. The COM DNS server replies with the same answer. It does not know the IP address of www.google.com, but it knows the IP address of google.com. So the DNS server, which in turn returns to the local DNS server. The local DNS server then asks the google.com DNS server for its IP address. It then replies with the IP address of the corresponding www.google.com, which it has. So the local DNS server then sends the IP address back to the client's computer that sends the request. Now let us see what is DNS lookup and how does it work. For most situations, DNS is concerned with the domain name being translated into the appropriate IP address. To learn how this process works, it helps to follow the path of a DNS lookup, and it travels from a web browser through the DNS lookup process and back again. So let's take a look at the steps. So first of all, a user types example.com into the web browser and the query travels into the internet and is received by a DNS receiver, recursive resolver. The resolver then queries a DNS root server. The root server then responds to the resolver with the address of a TLD server such as .com or .net, which stores the information for its domain. When searching for example.com, our request is pointed towards the .com TLD. The resolver then makes a request to .com TLD. The TLD server then responds with the IP address of the domain name server example.com, as you can see in the image which is given on the right. All of these steps are following the image. Lastly, the recursive resolver sends a query to the domain's name server. The IP address for example.com is then returned to the resolver from the name server. The DNS resolver then responds to the web browser with the IP address of the domain requested initially. Once the 8 steps of the DNS lookup have returned the IP address for example.com, the browser is able to make the request for the web page. The browser makes a HTTP request to the IP address. The server at that IP returns the web page which is rendered in the browser. Now after looking the NS lookup, now let us understand what is DNS resolver. So the DNS resolver is the first stop in the DNS lookup, and it is responsible for dealing with the client that made the initial request. The resolver starts the sequence of queries and that ultimately leads to our URL which being translated into the necessary IP address. It's important to differentiate between a recursive DNS query and a recursive DNS resolver. The query refers to the request made to a DNS resolver requiring the resolution of the query, whereas a DNS resolver is the computer that accepts a recursive query and processes the response by making the necessary requests. Now, what are the types of DNS queries? So let us differentiate between recursive and non-recursive query. So first of all, a recursive query. In a recursive query, a DNS client requires that a DNS server, typically a DNS recursive resolver, will resolve to the client and either the requested resource record or an error message if the resolver can't find the record. Whereas in a non-recursive query, typically this will occur when a DNS resolver client queries to a DNS server for a record that has access to either because it's authoritative for the record or the record exists inside of its cache. Typically, a DNS server will cache the DNS records to prevent additional bandwidth consumption and delay the upstream servers. So now let us talk about the types of DNS records. So DNS is unique. It can either utilize UDP or IP protocol or a TCP or IP. TCP is transaction control protocol, which is used to send a message. But DNS by default uses UDP. But if the message is too long, let's say the length of the message reaches 512 bytes, then the DNS is smart enough to utilize the TCP. Now, there are several types of DNS records that are kept by a DNS server. First, A records, which is basically just used to give the IP address for a particular host name. Second is our CNAME records, which is basically used to give aliases for our host names. Now, let us talk about a very important feature of DNS, that is DNS caching, which is generally used in our day-to-day life. So, The purpose of DNS caching is to temporarily store data in a location that results in the improvements in the performance and reliability of our data requests. DNS data can be cached in a variety of locations, each of which will store the DNS records for a set amount of time determined by a time to live server, that is the TTL server. Now, the modern web browsers are designed by default to cache the DNS servers for a set amount of time. The purpose here is obvious. The closer the DNS caching occurs to the web browser, fewer the processing steps must be taken in order to check the address. When a request is made for a DNS server, the browser cache is in the first location of the requested record, which basically reduces the time to search for a particular hostname. So DNS caching is generally very helpful, and in the modern days, each of the web browsers by default uses DNS caching. So there are several tools for monitoring the DNS information. First is the Whois tool. So it basically tells about the user and the primary DNS servers associated with the domain. The second, one of the most important tools, is our NSLookup. It basically tells you the IP address for a particular hostname on the internet. For example, when we write a command -nslookup www.gmail.com, it will tells you the IP address for this particular hostname. So, what is on? So this online NSLookup is a web-based DNS client that queries the DNS records for a given domain name. It allows you to view all the DNS records for a website. It provides the same information as command line tools like dig and NSLookup from the convenience of your web browser. So the nslookup.io does not cache the DNS responses it shows, but the DNS servers that are queried usually do respond with a cached record set, except for the authoritative DNS server. They never serve the cached DNS records. So now let us talk about the features of DNS. There are many DNS features. We are covering a few like global distribution, scalability, etc. So now let's talk about first of all global distribution. So that first of all, the data is maintained locally, but we can retrieve the data globally. No single computer contains all the DNS data. The DNS data, which I said about, like acts like a phone book for the internet. So this phone book contains data in different number of servers and computers. Now, the lookup can be performed by any device. It can be this routine can be followed by a mobile, a laptop, or a basic PC, or through any basic device. Next is the remote DNS data is locally cacheable to improve the performance. Now let's talk about the scalability. There is no limit to the size of the database. A database can contain any amount of data. One server has over 20 lakh names. There is no limit to the number of queries. Around 24,000 queries are occurring can be handled per second can be handled easily. Queries distributed are among master slaves and caches. DNS is dynamic. Databases can be updated dynamically. Modification of the master database triggers the replication of data. Another feature is reliability. Data is replicated. Clients can query master server. Clients will typically query local caches. Apart from them, DNS has many other features like it is the only system of its kind that will allow you to browse and use the internet. Its use is necessary for most companies and the people across the world. Without this system, it would be impossible for the people to access the internet, and the internet has become an essential part of our society. Another feature is that we do not need to memorize the IP addresses. If there was a world in which DNS was not involved, then we have to learn basically the IP addresses of our basic websites. So the domain names makes and give a kind of a sense to hyper the links when the name is given instead of a string of numbers. It is easy for categorizing, archiving, and helping the search engines. DNS enables you to specify the technical functionality of the database service. It can define the DNS protocol, the detailed specification of the data structures, and the data communication exchange used in the DNS. DNS is used as a form of load balancing or an additional layer of security. Thank you. That's all from my side.